Hi there, I'm Hao, and this is just another video of me solving random code problem. So let's begin. Given an n by n binary matrix grid, return the length of the shortest clear path in the matrix. If there is no clear path, return -1. The clear path is in the binary matrix is the path from the top left to the bottom right, right? And clear means 0. Okay. And all the visited cell of the path are 0. Okay. All the adjacent cells of the path are adirectionally connected. So they have 8 neighbors. The length of a clear path is the number of visited cells in this path, right? So we can visit the 0 here, right? Which is 2. Pretty straightforward. Right here, right? You can the shortest path is from here to here, 4. Not here, right? This will check another extra cell. So whenever I see a shortest keyword, I would think of the shortest right here, sorted clear path. I would think of like using a breadth first search. So we can do that, right? Our first level is the top left, right? Top left corner. Here, if it is 1, then we just like gonna return, right? Yeah, the grid is either 0 or 1. Okay, yeah, we return -1 here if we don't find a valid path, right? Yeah, so we can just check like our top left and the bottom right. If they are not even 0, then we might as well just like not bothering. So let's try that. What do we want to do here? We want to have a queue, right? So equal to, and now I'm gonna use a custom queue because in JavaScript there's no built-in queue. If you use another the language that have a built-in queue, please use it. Okay, use a couple of constant rows equal to width of length, right? And then column equal to width 0.length. Okay, and then what do we want to do here? We want to iterate through the y width.length, right? You want to do something here. You can return -1 at the end, right? If it's not possible to find a path like that, and we can check like if the grid at 0, 0 is not 0, right? Or the grid at 0 -1, right? Columns -1, it's not 0, and just like return return 1. Or we can do a condition. We want to make sure they are equal to 0. So if they are equal to 0, right? Then we're gonna do something, right? If this doesn't pass, then we're just gonna return -1 here, right? So if both the starting and then we want to add the starting node to our queue, right? Which is 0 and 0 here. We also want to keep track of the distance, right? The first node will be 1, right? Because the first level here is 1, like when we jump to the second level, it is 2. So it will be 1 here. Oh, actually this is NQ. Okay. What do we want to do now? We also want to keep track of the visited node, right? So if starting from here and we look at there's three neighbors, right? And only one is 0, we can come here right? But if we are here, then we can, we don't want to go back, right? So we want to keep track of the visited neighbors. So instead of creating a set for that, I'm just gonna do it in place by setting it to 0 or to 1, sorry. Because 1 is not a valid neighbor anyway, right? We only want to find a clear path. So we set it to 1. Okay. We want to look at the row, right? The column and this one is equal to q dot dq, right? And if the row is equal to, what is our base case here? Row equal to row minus 1, right? And column equal to columns minus 1. We just return the distance, right, immediately. And if not, we keep iterating, right? So we look at the neighbors and keep going. So what is the neighbors passing in the row and the column? So we can create a helper function later. So for each new row, new column. Okay, and then we just want to add it to the queue, right? Queue dot enqueue, row, new column, and then just then the plus 1. Because we are on to the next level now, so we want to add 1 to that. And we also want to mark it at like visited, right? So create a new row and then new column is equal to 1, right? We mark it as visited. We have to mark it here, like not up here, right? Because if we have two neighbors, right? If we have two neighbors like A and B, right? A and B, when we, so let's say we are, the corner node is C, right? We have two neighbors A and B, right? So we add A and B in here, right? So the next time we look at A, right? A also have two neighbors C and B, right? So because we haven't set the B, so if we don't set the visited node here, A and B, right? We wait until up here when we actually process the A, right? So we add A here. So the A, we look at two neighbors again, which is including the B. So we will have the duplicate. So that is why we need to add it as we iterating our neighbors array. Okay, so that's really much it. We just have to create our neighbors now. Neighbors is equal to row and column, right? And we can return. So there are eight. There are eight neighbors, right? 8 possible neighbors. So we can create a direction. Right? Let's create that. So direction equal to 1 0 1 0 0 -1 0 1 -1 -1 -1 1 and 1 -1 and then 1 1 no. So this is a possible direction. We can do direction dot map of it is dx and dy, delta x and delta y, right? We want to map it to row plus the delta x and column plus the delta y. And we can filter it to make sure it is inbound, new row and new column, right? Make sure it's inbound and new row, new column. So what is a valid neighbor? A valid neighbor is the neighbor that is inbound, right? And it has to be a 0 because we are following a clear path, right? And we also need our inbound function. um, inbound. Okay, equal to row and column. Make sure that row is not negative. Column is not negative. Row is less than row. Column is less than columns. Yeah, so that's pretty much it. We get our neighbors, right? We have a direction, and a valid neighbor is the neighbor that is inbound, right? And then it has to be a zero because we're looking at the a clear path, right? So if the starting point and the ending point is not zero, then we're just not gonna bother to do anything. We're not gonna bother to add anything to our queue. So that's just gonna return -1 here, right? Um, if they are zero, then we will try to find a path, right? We keep finding the neighbors here, and then for each neighbor, we add it to the queue, right? With the distance +1. So each level would be 1, right? And just accumulate to the total distance. And then we mark them at visited, right up to 1. Instead of creating a set to keep track of the visited node, let's set up some space. So our space complexity would just be the queue here, right? Would just be like O of n by n. Then for the time complexity, so the worst case, we only process each node 1. Yeah, and let's give it a try. Okay, accept it and work. Thank you for watching.